Welcome to today's explainer. Okay, let's dive into this because we are looking at a truly groundbreaking research summary straight from the US Department of Energy. It's all about a totally new kind of camera sensor. And we aren't just talking about a minor upgrade in megapixels or a slightly better low light mode today. No, we're looking at a fundamental shift in how a camera actually interacts with the physical world. Let's take a look at what makes this so revolutionary.
Now, what's really interesting about this slide is how it completely flips our basic understanding of photography right on its head. Think about it for a second. We're so used to cameras acting as passive gatherers of light, but the source material explicitly highlights that this new sensor begins analyzing the image right inside the detector itself. It's essentially starting to process and will understand the scene before the picture is even fully taken. It is a massive shortcut in the way machines see.
Section 1, the normal processing chain. Let's move to and see how this builds so we can truly appreciate how wild this new technology is by grounding ourselves in the status quo of conventional digital photography.
All right, here is the baseline of our current processing chain laid out step by step. Step 1, your camera lens captures the incoming light as raw analog data. Step 2, it sends that unorganized data over to a computer chip, usually an image signal processor. And step 3, heavy computational processing happens to convert that raw sensor data into a recognizable digital image. Basically, all the heavy lifting, all the actual understanding of the image happens entirely after the fact. And as you might guess, doing it this way demands a huge amount of processing power, battery life, and time.
Section 2, computing with light. Here's where we see a massive paradigm shift. Researchers have actually moved beyond that old three-step method. They've created photodetectors that are doing so much more than simply catching photons. They are literally computing with the light itself.
And this brilliantly illustrates the stark difference between the two approaches. A normal camera passively captures light, sits back, and waits for a computer to do all the complicated math. But this new intelligent sensor analyzes the image directly inside the detector. It's an instantaneous analysis method that essentially merges the act of seeing and the act of computing into one single fluid action.
The true innovation lies right here. The physical response of these photodetectors to the incoming light actually classifies the optical information directly. So instead of translating light into digital ones and zeros for a completely separate processor to figure out later, the physical materials inside the hardware are inherently designed to react to specific wavelengths of light. As the light hits the detector, the physical hardware naturally sorts and filters the data organically based on those wavelengths. By relying on raw physics rather than digital algorithms to classify the optical information, it entirely cuts out massive amounts of conventional digital processing. It's elegantly simple from a hardware design perspective, but scientifically profound.
Section 3, reality check, just an analogy. So, the crucial point is, when we use exciting phrases like the camera starts thinking, we have to be incredibly precise about what the researchers actually mean, just so we don't get carried away by science fiction. Right, we want to ensure we aren't mistaking this for some kind of conscious artificial intelligence living inside your smartphone lens. The Department of Energy summary notes that thinking is just an easy, helpful analogy for us to grasp the concept. What we're really talking about here is optical computing. This is an experimental technology that uses the physical, natural responses of materials to light to process information. It's raw physics doing the math for us, not a literal human-like brain inside the detector.
Section 4, the future of sensors. With that important limitation in mind, let's transition into the final payoff of today's explainer. What do these light computing photodetectors actually mean for the future of image capture? How is this going to change the devices we use every day? The capabilities of this new sensor, based on the research, are absolutely incredible. Because the sensor leverages colored light spectra and distinct wavelengths, it enables instant object classification. The camera essentially knows what it's looking at the exact millisecond the light hits the detector. And because it handles all of this right at the hardware level, it drastically slashes the heavy digital processing usually required. The end result? Cameras that are much faster, leaner, and incredibly energy efficient. Which brings us to the ultimate provocative question this research poses. Could future cameras understand what they see before creating a normal digital image? Imagine a world where a security system, a self-driving car, or even your mobile phone instantly comprehends its physical environment before a standard digital file even exists. The implications for processing speed, data privacy, and the future of technology are absolutely massive. That is the real power of computing with light. Keep asking questions, keep looking closely at the world around you, and I'll